Hello everyone, welcome to my class. In today's class I'm going to cover graph of tangent functions and graph of cotangent functions. In our last class we graphed the sine functions, cosine functions, secant functions and cosecant functions. So let me start the class right away. First, quick recall. The tangent functions is the ratio of sine functions over cosine functions. Cotangent function is the ratio of cosine functions over sine functions, and also cotangent function is the reciprocal of tangent functions. The graph of tangent and cotangent satisfies the following common properties. Both are odd functions. The range of both functions is whole real line, and the period of tangent function and cotangent function is pi. A summary chart for all t and integer k, the tangent functions, cotangent functions, their domains here, their range is here, period is pi, both functions are odd functions. The tangent functions zeros is at pi k and cotangent function zeros are at pi half plus pi k. They have asymptote. The tangent function is increasing in its entire domain and cotangent function is decreasing in its entire domain. And by the way, the domain of tangent functions does not include those points t equals to pi half plus pi k. These are the zeros of cosine functions. Similarly, the domain of cotangent function does not include the point t equals to pi k, because t equals to pi k are the zeros of sine functions. Great. So I hope this table makes sense to you all. Now next, let's talk about the table of values for t between 0 to 3 pi over 2. So here, we already know those values of sine t and cosine t. Now the values of tan t, just divide the value of sine t by cosine t at those respective angles. So here, the tangent is increasing from 0 to undefined in the first quadrant. Similarly, the cotangent function is decreasing from undefined to 0 in the first quadrant. And similarly, we can find the values of tangent and cotangent in other quadrant as well. So now let's graph. Let's graph tangent t between 0 to 2 pi. So let's begin the solution. Some fact I put together here. The tangent function is odd functions, so it is symmetric about the origin. The tangent function is increasing. It has period pi and its range is whole real line. Tangent function has vertical asymptote at pi half plus pi k. The tangent crosses the t-axis at pi k, means these are the zeros. So the zeros of tangent functions are at 0, at pi, at 2 pi. The zeros of tangent functions are the zeros of sine functions. The tangent function is positive in first quadrant and third quadrant, increasing in its entire domain but has no max and min values. Now let's put those informations and graph the tangent function. So here, let me talk first in the first quadrant from 0 to pi half. The tangent function has 0 at 0 and undefined at pi half and increasing here. Similarly, in second quadrant, means from pi half to pi, it's increasing again. At pi half is undefined and increasing goes to 0 at pi, and in third quadrant it's increasing as well as positive, so it lies above the t-axis. It's increasing and it's undefined at 3 pi over 2. Similarly, in fourth quadrant, this is the graph. I hope this makes sense to you all. Now let me use a technology to graph the tangent function, so it's nicer looking awesome graph here for the tangent functions. I hope it makes sense to you all. Now next let's graph the cotangent functions. Again, let me go over the facts that we know so far about the cotangent functions. The cotangent function is odd functions. It is symmetric about the origin. It's decreasing. Cotangent function has period pi, and its range is whole real line. Cotangent function has vertical asymptote at t equals to pi k. The cotangent function has vertical asymptote at pi k. Those are the zeros of sine functions. We know the cotangent equals to cosine over sine, and the cotangent function crosses the t-axis at t equals to pi f plus pi k. These are the zeros of cosine functions. The cotangent function is positive in first quadrant and third quadrant, decreasing in its entire domain, but has no minimum and maximum. Now let's graph the cotangent functions. So now here, let me go over in first quadrant from 0 to pi half. The cotangent function is undefined at 0, so it starts from there, and at pi half it's 0, so it's decreasing. Also the positive means it lies above the t-axis, and in second quadrant cotangent is negative, so it lies below the t-axis, so it decreases from pi half to pi. It has vertical asymptote at pi. Similarly, we can graph the cotangent functions in the third quadrant from pi to 3 pi over 2, as well as in the fourth quadrant 3 pi over 2 to 2 pi. Great. I hope this graph makes sense to you all. So let's move on. Now in example 3, I combine the graph of tangent functions and cotangent functions in the same plane. So here, the blue is tangent functions graph. This is, look, this is increasing, and this is increasing, this is increasing. The tangent function has asymptote here at pi half, at 3 pi over 2, and so on. And we know the cotangent function is the reciprocal of tangent functions, so the cotangent function is decreasing here. In first and second quadrant, it has vertical asymptote at pi and 2 pi, and the cotangent function is decreasing in third and fourth quadrant. Cotangent function is decreasing in its domain, whereas the tangent function is increasing in its domain. I hope this comparison makes sense to you all. Now let me use the technology here so that the graph of tangent functions and cotangent functions are here. Great. So I hope this comparison makes sense to you all. So great. So by now we finished graphing all 6 trigonometric functions. In our earlier class we graphed 4 trigonometric functions, and today we graphed 2 trigonometric functions, cotangent and tangent. So we finished graphing all trigonometric functions. Great. Now let's move on. Now example 4, find the values of questions A and B. So in part A, let's compute the values of tangent of negative pi fourth. Let's begin the solution. Since tangent function is odd functions, so tan of negative pi fourth equals to minus tan of pi fourth, then minus as it is. Then tangent function is the ratio of sine functions over cosine functions. So this is step, and the next step, the minus as it is. We know sine pi fourth is 1 over radical 2, and cosine pi fourth is 1 over radical 2. Cancel out, it gives us negative 1. So tangent of negative pi fourth is negative 1. By the way, this lies in fourth quadrant. Awesome. Let's move on. In part B, let's find the value of cotangent 3 pi over 4. We know the cotangent function is the ratio of cosine functions over sine functions. So this ratio is coming from the definitions of cotangent functions. And next step, cosine 3 pi over 4 is negative 1 over radical 2. Sine 3 pi over 4 is 1 over radical 2. This cancels. Again negative 1. Questions 5. Find the asymptotes, zeros, and period of 2 times cotangent pi t in intervals -1, 1. Awesome. Let's begin the solutions. The period of these functions, pi over the coefficient of this angle t, which is pi, so pi over pi, which is 1. So the period is 1. Asymptote are at t equals to pi k. So pi is a period is 1. So at k, t equals to k, since k is an integer, let's put k equals to -1, 0, and 1, because these are the integers lying in this interval. So at t equals to -1, t equals to 0, t equals to 1, we have asymptote. So at -1 asymptote, 0 asymptote, at 1 asymptote. So and the zeros are at t equals to, by formula, pi half plus pi k. Since pi is 1, so in the next step, 1 half plus k, and put k equals to 0 and -1. So k equals 0 gives us 1 half, k equals to -1 gives us 1 half minus 1 is minus half. So zeros are at t equals to -1 half and 1 half. So here, 0 here means crosses the t-axis at -1 half and at +1 half. Great. I hope this makes sense to you all. Now we finish these sections. Thank you.